In this video, we're going to write a script which resizes this JPEG image. It will make it smaller given a scale percentage that we can give to Python. So to do this, we need to import CV2 and start by loading the image into an image OpenCV object, which goes like this: CV2 im read galaxy.jpg. And if you print out image.shape, you're gonna see the shape of the image, which means that this first number here is the height of the image, because you'll see that this image here is sort of vertical portrait mode. So this is the height here represented by that, and the width is the second number, and 3 means there are 3 matrices with this height and width, and each matrix has different values, different pixels. So for red, green and blue, so every pixel of the image is represented by a mixture of red, green and blue, as we have discussed previously. However, the colors are not of any interest for us, because we are only interested about the size of this image for now. So that is how you get the dimensions, and you want to calculate the new dimensions now, right? Now, when we're talking about calculations, it makes more sense to have a function define calculate size, so which gets a scale percentage as input, and it also gets a width and a height perhaps, and then it calculates the new width equal to width times scale percentage. So with scale percentage, what we expect to have here is something like an integer or float. So for example 10, which means make the new image 10% of the size of the old image. So we should say, for example, let's say the original height was 779, so we would multiply by 10 and divide by 100, and we get the new dimension. That's what I'm doing here. Width times scale percentage divided by 100. I'm going to copy that, paste it here, and this is for new height equals to height. The scale percentage is the same, and so on. And then return. I would return a tuple here with new width and new height, right? We have an underline here, which means, yeah, undefined name width, because I mistyped it here, WD, which it should be, yeah, now it's fine. So let's test this function first to make sure it's working fine. Scale percentage, let's say 10 for width. Now the width will be image.shape 1. I'll explain you why. 0. Right, that should do it. So what is this? Well, image is the image object, right? Image.shape, this one here, gave us this tuple. So image.shape is a tuple, and 1 is the second item, which is the width, and 0 gives us the first item, which is the height. So the width, the height, the height. I think it makes sense. Run. Yeah, so this is the new dimensions, width and height. Now that we have that, we could go ahead and create another function which could say something like resize for resize image, and this would get an image path as argument and a scale percentage argument, which is a local argument, a local variable of this function, right? And then we would get this here and paste it in here, so indent under this function, and instead of saying galaxy.jpg, we say image path, and then cv2.resize. Resize would get as argument the source, which is the image object, and desize, which I'll tell you what that is. So image, this one in here, goes here. So we want to resize that image object. And the desize now is something that we want to get from this function. So that is desize, the new size. Therefore, I'm going to say here new dim for new dimensions equal to calculate size. Scale percentage is the first argument that this function gets. So you see here scale percentage, and also width, which is image. Yeah, this one here, let me cut it. That is the width. And the height has an index of 0, right? So let me delete that part and that as well. And then here we say new dim, right? So the resize method of CV2 gets the image object and the new dimensions as arguments. But you need to know that this method returns another image object. So let's call this resized image. And then using cv2.imWrite to write this resized image into an actual file. So you could give this a file name for the new image, such as resized something, or you could make things better and say resized path. So when you call the function, we want to provide that path as a string in the function call, not hard code the string in here. So resized path goes here as the first argument, and then the resized image. That's what imWrite expects, the file name and the actual file object. Now we can call this function. So what we'll do now is we'll call this function given these 3 arguments. When we call this function will call the calculate size function, given the scale percentage, which it will get it from here, and so on. So resize image path. This is the original image, galaxy.jpg, scale percentage 10, resized path. How about resized galaxy.jpg? Or you could also create a variable here, such as name equal to galaxy.jpg, and then use an f string here. But let's keep it simple. We could do that later. Let's try it then to see what errors we get. So can't parse desize sequence item with index 0 has a wrong type. Desize. So desize was an argument of resize. So you see desize is the second argument, which is expected to be a tuple. So new dim is given here, and new dim is actually a tuple. You see, we get new dim from the return of this calculate size function. So this is a tuple, you see the parentheses. And this is saying that the sequence item with index 0, so the first item of this tuple has a wrong type. So this item, new width was defined in here. So this is the wrong type, it says. And I know that the type, since these are dimensions, it should be an integer. But since we are dividing this here, this is probably a float. Therefore, we could convert this into an int and do the same for height. Convert them both into ints, and then we make sure that this will get an int and this will get an int as type. So run again. And you see a resized galaxy was generated in here. It looks small, so even though REPL is opening up here, it's stretching it out. You see that we only have these number of pixels, which if you like, you could also print it out in here, print new dim and say new width, new height, run, and now you get some outputs in the command line as well, which is more user-friendly. So that was the original image, this is the Resize image. 10% was quite a low value to apply, so usually you want to do something like 50% or higher when you want to resize the images. And that is how you can resize images, and this is how I would do it. So I would use these functions to separate things, because the advantage of this now is that if you want to resize multiple images, then all you have to do is just write a for loop which iterates through a list of image file paths, and then in each iteration you call the resize function and provide as image path the current file path of the current iteration, and so on. So thank you for following. I'll talk to you later again.